Hi everyone, my name is Curtis Reese. I'm a solutions architect with AWS. Today we're going to be talking about a topic that's near and dear to my heart, Amazon CI/CD practices for software development teams. I've spent many years as a development manager and operations lead helping development teams implement DevOps best practices. So if any of you are interested in that, which I hope you are, this should be a pretty interesting webinar for you. So let's go ahead and get started with a bit of an overview. We're going to give an overview of continuous integration and continuous delivery. We're going to explain why it matters, go into some of the tooling and techniques, and in the end, kind of bring it all together. And if there's time, we'll do some high fives and Q&A at the end. So what is continuous integration? Well, the idea of continuous integration is developers regularly commit code to a source code repository. And then after it's committed, it triggers an automated build process that'll go through and build the code and build the application, which will then trigger a series of tests during that build process that will provide developers regular feedback as to whether that code is building, if there's any errors or anything that they need to be aware of that will prevent that code from being successfully deployed in later states. And that's it at a high level. So what is continuous delivery? Well, continuous delivery is the idea of taking the CI steps and extending them a little bit. So adding deploy, test, and release. So it's the act of taking that built artifact and getting it out to production. So it starts with deploying the built artifact. So we're going to go through and make sure that it can get deployed to a staging and pre-prod environment. We'll then run a series of automated and manual exploratory tests on each of those tiers to ensure that the application is functioning the way that we expect it to function in a deployed state. And then based on the outcome of that, we'll determine whether we can deploy it to production and actually go through a release process. And so this can either be a manual or automated process. Ideally, it would be an automated process. But the idea is CI/CD together is kind of a flywheel of all of these together. So why does CI/CD matter? Well, every year, Puppet Labs does a DevOps report. It's kind of like a state of the union of DevOps. And what they found are a couple different focus areas that we'll cover here. So basically, they polled everybody, and they found that when these processes are implemented, it's easier for development teams to find bugs earlier in the process and fix them faster. So overall quality goes up through the process of implementing CI/CD by about a series of 5 times lower change failure rates. So if something goes wrong, you find it almost immediately and you can fix it faster. So changes before they get implemented or pushed into the code, they get addressed almost immediately. What this also means is that you can go from commit to deploy about 440 times faster. So the idea is you can get code out more quickly, and because of that, you can actually deliver more often. And by virtue of that, you can deliver more features and capabilities to your end customers, hopefully meeting their needs. And as you can assume, this is probably pretty important for most companies. They want to be able to deliver on their customers' needs and provide more value to them as quickly as possible. And they can deliver 46 times more frequently. Additionally, what they found is that because we're able to release more frequently and we're able to focus on new features and capabilities, we're able to unblock a lot of developers. They'll spend 44% more time on new features and code, which keeps developers happy, that keeps them interested, and they can grow their skills a lot faster. So let's go into some continuous integration tooling. For the sake of today's demo, we're going to be showing off Amazon CloudWatch to handle events and monitoring. We're going to be using AWS Code Commit as our source code repository, as well as GitHub. So we'll show examples of both of those. And then for build and test, we're going to keep it simple. We're just going to focus on AWS Code Build. We'll introduce Code Pipeline later in this conversation, but for the sake of CI, we just want to keep it simple. And the idea here is you can integrate with whatever tools you need that match your team's capabilities and their skill set. So the example that we're going to use today is just a simple calculator application. It's written in Node.js, and basically it's just going to it's a very high-level app that's going to run some unit tests and have a couple of functions. The important thing that I want to call it is we're going to be using AWS Code Build for the build portion of this. And AWS Code Build is essentially a fully managed solution that provides containers that you can build and include your license or your libraries in. So whatever you need to build your application, you can custom tailor that base container image to include what you need to build your application. You can parallelize your build so you can You can run multiple builds at the same time. It scales up as you need, and because of that, it's also pay as you go. So you're only paying for when you're actually in a build process. And like I mentioned, it is extensible. So if you need additional libraries or you have a complex build that requires multiple application platforms, Java and say Node, you can put that in your image and move forward. So this is an example of code build. So this is a list of projects that we have here. So we've got our Node Calc integration test example. Build project is pretty straightforward. We're going to go in and create one here, and this will provide project names, some descriptions. It'll show off a specific repository we're pulling from. So this repository is pulled from code commit. We can look at the build specification file. So this is what we define, where we define how our build phases work. And then we have the base image that we're going to be using for this application. So like I said, this is a container image. We're using Node.js 4.3.2 as the example image. There's newer versions out, but this is what we're using as our base. So if we go into the build spec, this is where we get to specify the various phases of our build process. So you can see we've got an install phase, and it's going to run npm install. We've got the build process, which is going to go and execute our tests. And then we can specify where specific artifacts are going to be stored or found. It's very simple. It's a YAML structure, and all of your build processes are going to have this. So once we go through here and we've created this build, we can go into the build history and actually see the history of this build, whether it was successful, whether there were specific failures, and then we can dive into each of those. So if we look into this particular build, you can see the status of this build was succeeded. We can see when it ran, how long it took to execute. And then we can go down and see the different phases of the build and see the success of each of these, or success or failure rates of each of these, as well as how long it took to complete. So this gives us a lot of insight into the build process itself and whether it's being successful or not. So if we scroll down, we can also see the build logs. So we get a lot of detail about the particular build and anything that we output from it. So this is a chance for you just to at a glance kind of see what's going on with your builds. So how do you do this? Well, looking at this continuous integration journey, this is the flywheel. We want to get you going from an immature state to a mature state as quickly as possible, and the automation steps around this will help you speed that up. But let's look at it in a more practical sense. With limited integration, you're going to be going at the speed of, say, a bicycle. We use this analogy. As we introduce more integrations and more automation, you'll be going at hopefully the speed of a car, and the goal is to get you up to the speed of a steam locomotive. So you're going full speed through delivery. And what this equates to, through the sake of this example, is nightly checks versus branch checks versus pull requests. So if we look in the context of nightly checks, this is the idea of building your code in an automated state once a night. So middle of the night, you're going to trigger an automated build using CloudWatch events, and it's going to basically make sure that that application still builds and compiles. This isn't necessarily ideal because there's a period of time where your developers aren't getting that real-time feedback, and there could be multiple commits throughout the day. So there could be a chance that in the morning we find out that bad code has been introduced to that particular code repository, and now developers are stuck, and we've got to go through and figure out which commit actually caused that and then fix it. Second phase of this is going through and implementing it branch checks. So after a developer's committed code, we trigger a build and unit tests to make sure that that branch still builds. So the challenge here is we've automated a little bit more, but it's still after code has been committed to that branch. And if we find out that that build fails, developers are still stuck, and we either have to undo that commit or provide a patch for it. So the idea here is we want to get to this pull request checks, which is, as soon as the developer submits a pull request to get that code reviewed and committed to a particular branch, that's when the build is executed and the tests are executed. So before code is committed to the repository, developer basically says, look, this is ready for review. We run through the build tests. It looks like it passes. And we know that that code is ready to be committed. And this is where we want to go. It's near real time. As the developers still have it fresh in their head, it's, they're going to be working on it. And if a build fails, we'll know almost immediately, and the developer can go in and fix it immediately. So for the sake of today, we're going to focus on pull request checks. So let's look at this in the context of code commit. So the idea here is a team member is going to propose a pull request to code commit. That will then trigger a CloudWatch event, which is going to notify code build to then go through and trigger a build. Code build will then report back through a CloudWatch event to code commit. to notify whether that was successful or not. And so we can get near real-time feedback, or as close to real-time as possible, whether that build is successful or not. So if we go into code commit, we've got our branch here. So we've got the subtraction branch. We're going to create a pull request. So we're going to go in here. It's going to tell us whether this particular change or branch or this particular code can be merged with the branch that we're looking at. We can go in and provide some specific details about it. So we don't have any tests for this. We're going to see the code that we're introducing. For the sake of this demo, we know this is going to fail, but the developer at this moment doesn't. So they're proposing this particular change. That pull request has been created. And we can go into the activity tab and see the pull request is created. And we can start to see some more activity as this continues to go through the build process. So we can see that particular pull request has been in process of being built. And then we see that it failed. So in code commit, we can see that output from that build to see that there's an assertion error with our unit tests. So we can go back and provide a fix for that error, and subsequent commit, and then that subsequent commit will then go through and trigger a build again. And what we see, or we can see with this particular change, is we've made a modification, we removed some code. And we can see that this particular build is in process again, and now it's succeeded. So this is real-time feedback on this particular build. So if there's a problem, the developer can immediately deal with it while it's fresh in their mind. And once it's succeeded, the review team, whether that be software development leads or a particular team in the organization, can go through and then know that that code is ready to be reviewed and then potentially merged with that particular branch. So looking at this in the context of GitHub, it's a very similar process. The team members propose a pull request through GitHub, which then triggers a webhook to code build, which will report back to GitHub whether that build was successful or not. So if we look at it here, going into the project within Claire's, one of our developers' environments. So we're going to the settings here. We've got the URL for code build that we're going to use as a trigger. We're providing specific credentials to get access to that. And then we're going to set this to be triggered on a pull request. So now we go back to our branch. We've got the subtraction branch. We're going to create a pull request. It's going to go through. You can see we've got this code change that we're adding. It's going to trigger that build through that webhook. You can see in real time the checks have failed, and this particular build has failed. So we go back, provide that fix like we did last time with code commit. It's going to trigger that build again, and we can see now that that build has succeeded. So the idea here is now the development teams know that they can go through and review this, and it's good. So what are some other speed boosts that we can do? Well, we've got the idea of integration tests and parallel builds. Let's focus on integration tests. So the idea is, as developers continue to introduce new features and capabilities for their code, they're going to introduce new needs for integrations. So say we've got a new feature that requires a Redis cache. We get this scenario where it works on the developer's machine, but when they go to deploy to integrations, the builds fail, and now things don't work. So we can see in this little chat here, we're saying that suddenly we're getting no polling or exceptions with the code. Well, what happened? Well, in this example, we've introduced a feature that requires an Elasticache cluster. And on the developer's machine, they have a local Elasticache cluster, and the code is able to connect, and it works just fine. But when we integrate that to within our build process, the build environment in code build doesn't have access to that. So we need to modify the actual build process as we evolve our code base. And so we'll come in here, we'll see this particular build process or build project. We can see that it failed, and we can go into the build phase for this particular project, and we can see, yep, clear as day, we're getting an error with connecting to the Redis cache. And so what we're going to do is we're going to create a new build project called Node Calculator Integration Tests. And we're going to provide some specific details around a VPC that we're going to want that build to run in, and it's going to have specific security groups that are going to give us access to a Redis environment built in Elasticache. And we're going to execute that build process, and you can see it succeeded. So if we dive into it, you can see here, actually I'll back up, you can see the specific host that we're connecting to for Redis, and we've provided credentials through our security group. So when this build process runs and that container gets executed, it's able to make that connection, and when it runs the specific build processes and tests, it can go through and actually make that connection to that Redis environment. So another speed boost that we can do is the idea of parallel builds. So the idea here is that if everything is run procedurally and it's run as one build project, you're not getting a lot of advantage of the scale that you can get with code build, as well as parallelized builds in general. And the idea is if you break up your build steps into separate build processes, they can be executed at the same time. So rather than, some steps may take longer than others, you can get as near real-time feedback as possible. So you can see if there's a particular phase that fails or not. But what you get is more immediate response. You take less time because these things are executing in parallel. So let's dive into that a little bit. So the idea here is with the parallel build, the team member is going to propose a pull request, which is then going to go through and trigger the code build step, but it's going to trigger multiple builds. So if we see this is the context of the calculator app, again in GitHub, you can see Claire has her subtraction test that she's added, and it's going to go through and she's created this pull request. It's going to go through and trigger the build process, and you can see it's doing the node calculator GitHub build. So it's building the application itself. Now it's triggering a static code analysis build phase, and we're going to also do an integrations test build phase as well, or project. So we can see that all three of these are triggered around the same time, and they're going to come back and we can get details as to which ones have succeeded or failed. So we know that the application builds, but the code analysis is failing as well as the integration tests are failing. And the value here is we're getting this sooner than if this was all parallel or procedural, so one after the other. And we're also getting more details around what is actually failing. So we know this may not be a code issue because the application's building, but it could be a testing issue. It could be something else. So we know which team needs to be involved in troubleshooting this. And we also know that this code isn't ready for merging into our project. And so there's additional work that needs to be done. And we're getting that detail much more quickly. So the idea is through this automation process, we're going to get this immediate feedback to our developers. We're going to help speed them up, and we're going to get them to a state of CI nirvana. And it sounds cheesy, but that's the idea we want to get to. We want to make it so that they're able to get their features out, know when things are failing, know when things are working, and be able to move on to new capabilities. So let's look at this in summary. We want to be able to implement a build while code is still in review, so before it's committed. We want to tighten up that feedback loop. So if going back to that journey, this is the flywheel. We want to get this going as quickly as possible. So we want to shorten the time that it takes to build the code, and we want to make sure that we're not blocking any other developers on the team if code is broken or does fail a build. So we want to limit the team impact. And then we want to find additional ways to speed things up, doing integration tests or parallel builds. There's other opportunities here with things like caching specific libraries in S3. There's a lot of additional things that you can do in addition to this. But this is a good starting point when you're gaining maturity. So you want to automate the boring stuff, library upgrades, like I kind of mentioned. You want to surface failures. So think about ways to provide feedback to the developers. We're using an example of a team chat here. Well, that can be done through a series of integrations. So say you're using Slack, you can integrate your build environment with Slack, so it provides real-time notification when builds are failing. When if you integrate with Code Commit or GitHub, you can get notifications when pull requests are submitted. And the idea is you're getting that faster feedback, more real-time notifications and updates as to what's going on with your code base. You want to be able to cache things faster, so you want to check faster, so cache wherever possible, perform parallelized builds, and then you want to be able to check more frequently when there's for challenges. So implement things like integration tests to make sure that the integrations with things like databases or caching environments are still working as expected at regular times. So it builds. Now what? What do we do? Well, let's talk about getting it deployed. So moving on from the CI process, we're going to go into the deploy, test, and release process. And so some of the tools that we're going to focus on today are, for the sake of this example, are Amazon CloudWatch for monitoring. We're going to use Amazon SNS and AWS Lambda for software development. We're going to use AWS Code Build for build and test. And then we're going to introduce Code Pipeline for this portion of it. And so the idea is we're going to evolve our CI process to include Code Pipeline for this portion. And we're going to use Code Deploy to help actually get it deployed to our environments. So if we look at this from a journey, the idea is we're going to be We're going to constantly test the service itself. We're going to be managing the deployment health to ensure that as we deploy things to each of the servers in our environments, that the application itself, as well as the server itself, are healthy and functioning the way we would expect. We're going to figure out ways as we gain maturity to segment out production so we know how we're deploying this application and we're doing it in a safe manner. And then we want to be able to halt promotions through our pipeline in the event that something is wrong up the tiers. So the idea here is as we gain this journey, we're going to introduce a higher level of automation, going from like zero automation all the way up to a mature level of automation. But we're going to do it in a way that introduces that automation safely. So a lot of people are very scared of implementing automated deployments because the idea is, what if the build fails? What if deployments fail? We want to implement safety checks along the way, and that's kind of what we're going to get into a little bit here. So let's talk about continuous service testing. So the problem here is that a service can stop working or an application can stop working for reasons inside or outside of our control, and it may be unavailable without us knowing. And so it may be that if we have health checks on the actual application or the server, the health checks could be passing. It could be returning a 200. Say if it were just a web application, we're getting a 200 from Apache. But what it's returning may actually be incorrect. Imagine a store where suddenly the buy button is basically not functioning properly, or has disappeared, or prices are different than what they're supposed to be. We want to be able to implement some way to test that. So one of the ways to do this is using synthetic traffic to simulate real users. And so we're going to test all business and critical functionality. This includes UI and APIs, but it's not limited to that. We want to be able to run these quickly, so less than every minute, on average about every 60 seconds. We want to measure the latency that we're getting responses from our application, because if things are taking a long time, that's going to degrade experience for our end users. We want to make sure we're meeting that expected latency. We want to check for reachability. We want to make sure that maybe the health of the application or the server is up, but we're not getting a response from the web web application itself. So we want to make sure that we're able to get those responses. So how does synthetic traffic flow? Well, the idea is you've got a user that's going to make a request of your application running on an EC2 instance. That's going to report back to CloudWatch a success. So CloudWatch is going to get that CloudWatch log, and it's going to respond back. The web server is going to respond back to the user and display your website. Synthetic user and synthetic traffic are going to function the same way. Synthetic user basically comes in, makes a request. If the server serves that data, it's going to respond back to CloudWatch logs and send that traffic back to the synthetic user. But then we're also going to have another step where the synthetic user is going to report back to CloudWatch that, hey, everything looked good. And we're going to run this every minute. So that's the ideal that we're reaching towards. So CloudWatch events is going to trigger that. It's going to report back that the server delivered that web page. And the synthetic user is going to compare that against what the expected test would be, and say it fails, it's going to go back and respond to CloudWatch and trigger an alarm. But why are there two metric streams here? The idea is we want to be able to trigger, test the application or the server health, so that we know the server is responding, it's logging that it's returning expected HTTP codes. We also want to test that the end user is getting the expected output. So, in the event that the button says what it's supposed to say, or the website looks the way it's supposed to look, and then trigger an alarm based on the outcome of that. So building a synthetic traffic test, it's pretty straightforward. We want to keep it simple, so don't go overboard. Keep it simple to a couple different things, maybe one specific focus. Build the logic in Lambda and invoke it with CloudWatch events. If you do this in Lambda, you can use the free tier up to a certain amount. But the idea is you can trigger these very quickly. You don't have to maintain an infrastructure. It's going to be executed and scalable on the fly. It keeps it pretty straightforward. You can capture the data in CloudWatch metrics. So you have a metric, and we'll get into this a little bit later, but you have a metric for your web server, but you also have a metric for the CloudWatch synthetic user. And then if we dive into the specific Lambda blueprint for this, we have a blueprint you can use for synthetic testing. We call it the Lambda Canary test. Basically, you can use this as a base and kind of grow it from there. But the idea is we're going to create a CloudWatch event. We're going to specify the function we want to execute. We're going to specify the rate that we want that to go, and then we're going to give a description so we know what this particular test is. So if we look at the actual code here, you can see we're providing a URL for our application. We're going to be looking for specific text that we want to test against. And then we're going to open that site, read the site's HTML in, decide whether we found that particular text that we're looking for. If there's an exception, we'll print a failure. If it's successful, we're going to say it passed, and we're going to track that. And so let's look at alarming. So the idea here is that we've got a lot of metrics that we can trigger off of, and we want to make sure that we're triggering off the correct methods. So if we go into that particular Lambda function, we can see how many times it succeeded. We can see the number of invocations. We can see the error rates. And we want to trigger these on we want to trigger an alarm on specific metrics. So if this fails 3 times in less than a minute, basically trigger that alarm. We want to basically make sure that we're not overrunning it, but doing just enough to make sure that things are working or not. So find the right mix that's right for you. So we're going to run this every minute and basically see if it fails 3 times, and then it'll trigger that alarm. So if we look at this from a pipeline perspective, we've got this immature pipeline where we've got just deploy to production. It's going to trigger code deploy, which is then going to go and deploy our application to our 3 instances in our target group. And our synthetic traffic is then going to visit those websites and report back in. So let's dive into managing deployment health now. So if we look at the environment that we're running now, we've got an elastic load balancer. We've got a number of different instances in our target groups there that we're going to be deploying our application to. And we're going to do a rolling deploy. So we're going to trigger this deployment process, and code deploy is going to go through and actually deploy the application to each of those instances and put them back into rotation. So if everything goes well, this is great. It works, and our application is being served. What happens if it fails? Well, by default, code deploy is going to fail all of them. So it's just going to go through and just keep deploying, and it's going to deploy in a failed state because we're not testing the health of that application. We might be testing the health of the actual server itself, but the application may have failed the deploy, and now it's not being served properly. So we want to implement some simple tests to help prevent this kind of deployment failure. So the problem here is we're not automating tests to verify that the service is working, and that means that production deployments need to be checked manually, and that's not what we want. We want to automate that check. And so we're going to implement some safety in our rolling deployments. So we want to validate each host's health. We want to ensure the minimum percentage of the fleet is healthy before we count that deploy as a success. And if we don't reach that minimum healthy fleet, we're going to roll back and treat the deployment as failed. So let's look at configuring code deploy. So your application is going to include an app spec file, which will cover, similar to our build spec, it's going to provide some details over the phases of our deploy process. So we've got specific hooks. So we can do things at application start. We can specify where we're going to deploy the files to, and we can do some validation. So in this particular offering here, what we're going to do is provide a script that's going to be executed after our server has been started. And we're going to basically make sure this application is functioning the way we would expect from just a high level. Is it deployed properly? We're not getting any errors on the app, from the app server itself. So that's what we're doing down here. And so now if we deploy this, it'll go through and do the rolling deploy. And if it gets to a point where it fails, you can see it's not going to introduce that back into the load balancer. So that particular instance failed, but the rest of only the healthy hosts have been returned back into the load balancer. But because we had a failure, by default, this actual deployment is considered a failure. And that's not necessarily right, because you see from this example, we've got basically 90% of our hosts are healthy, only one failed. And so that's where implementing minimum healthy hosts kind of comes in. So the idea here is we want to specify that at least 70% of our deployment needs to be successful for this to be counted as healthy. We've got 10 hosts here. So the idea is, one failure is 90% healthy. So this build would actually be treated as a success. But if we go through and we run that build again and 4 of them fail, this one actually is treated as a failure, which is what it should be. We've got a serious problem here, obviously, because 40% of our hosts aren't being deployed to successfully. So there's an issue that needs to be resolved. In this particular scenario, we want to roll back. So how do we implement this? Well, within Code Deploy, you can come in and actually specify some details around your deployment configuration. And one of the options here is what we call 2/3 health. The way you would do this through the CLI is you can come in and actually specify some specific details around this deployment. We're going to specify the minimum health. We're going to use a value of fleet percent. We're going to provide a specific percentage. So we want, in this particular example, 66% of our fleet to be healthy and pass those checks in order for the build and deployment process to be deemed valid. And in the event that it doesn't pass that deploy, we want to be able to trigger this box that says roll back when deployment fails. And this is part of your build or your deploy config. So we want to make sure that if it doesn't meet that healthy host count, we're actually rolling that back and deploying to a previously healthy state. So let's look at this in context of our maturity of our pipeline now. So at this stage, we're now validating the host's health of each instance as we deploy our application to those instances. So we're evolving the automation, but we're also increasing the safety of our deploy. So if the number of healthy hosts is met, that deploy is considered successful and healthy. So now let's talk about diving a little bit deeper and evolving the segmenting of our production environment and how we treat the health of our deployment in general. How do we improve that health? So an example is when a critical issue reaches production, all hosts are affected. The consequence of that is bad changes impact all customers. So the idea here is, say you release something bad to production, say the code passes, it somehow gets through your health checks, but in production it's failing. It's not displaying what you'd want. You don't want that rolling out to all of the systems in production in a rolling change. So what we want to do is break things up a little bit in how we deploy to our production environment. So to do this, we want to break production in multiple segments. We want to deploy to a single segment at a time, and then test each segment after we deploy to that segment to make sure that things are working as expected. And then we want to repeat that 2 or 3 times until we've reached all of the systems in that particular production tier. And so what constitutes a typical segment type? Well, the highest level you can get is by region. It's the idea of running a particular day within a particular region. You deploy to that region. If things work, you can deploy to the subsequent regions and reach your customers throughout the globe. That's okay. I wouldn't recommend starting at that. If you dive down a little bit deeper, you can look within the specific regions. So for here, we've got US East 1, and we can break it up into availability zones within that. So we can target specific availability groups or availability zones and then target those as segments. That's good, but we want to take it one step lower. So now we're talking about subzonal segmentation. So deploying to a specific group within a particular AZ and then testing there. And even more ideal than that is breaking it up to a single host and treating that host as a canary. So these are all production systems. We're just grabbing one, expanding up the layers here. And so we'll start with a single host and then expand to subzonal, deploy to all availability zones within that region, and then if that region is successful, deploy to multiple regions. So let's look at this in the context of the deploying to production. So the idea here is at a minimum, we're going to implement some kind of canary, and we'll have the rest of the fleet. So this will be within one region. Ideally, this is what we want to get you to. So we're going to deploy to canary. We'll deploy to the first availability availability zone segment, and then deploy to the subsequent segments within that region. So the idea here is we're going to test each phase of this deployment. So we want to make sure that when we deploy to the canary, it works. If we deploy to the first availability segment, it works there. And make sure that is successful across the rest of the deployments. And so that is how we're going to validate the success of this deploy, one segment at a time. So let's look at how we do this. So one of the ways you can do this is to use tags and auto-scaling groups to target to group the specific instances so that we can target them through our code deploy process. And if we look at that, you can provide specific details here in your deployment group. So you can specify specific tags. You can tag one as canary. You can tag them as specific segments, and then have autoscale policies related to that. And if we look at it in the context of our evolving our code pipeline, you can see that we've got the various deployment stages. So deploying, once we pass our integration tests, we can then go through and deploy that canary. We have a stage for testing canary, then we'll deploy to the next segment, and then we'll run our tests. And if those tests pass, we can deploy to the rest of the application or the rest of the segments and validate that everything is working as expected. So let's look at this a little bit, go through this process. We're going to deploy to the small segment test, go through as I mentioned. So within each segment, a deploy is valid if the test has gathered enough data to gain confidence that it's successful. So we're going to look at CloudWatch metrics for that. We want to validate that no service alarms have been fired. So we're going to have CloudWatch alarms configured to make sure that things are working as expected. And we want to make sure that the test hasn't timed out. So we're going to use some code there to basically validate that we are getting responses back and we're getting them in the time that we're expecting. So we're going to need to extend code pipeline to be able to accommodate this. And some of the reasons for that is we've got various actions that we can use today, like test actions, Lambda invoke actions, and custom actions. But all these have a 1 hour timeout. And so for any step that we're going to have to go through and do some validation on, or that we want to extend, we can look at approval actions as an example of this. Say we want to release this to the next tier. We don't necessarily want to be limited by 1 hour. We want to go a little bit beyond that. We're going to look at approval actions, which have a 7-day timeout. And so let's look at using the approval action to trigger tests. And so we're going to validate that segment for canary. And so basically, we're going to have this approval step that'll go out, trigger an SNS topic. That SNS topic can typically be sent to an email. But one of the cool things about the SNS topic approach is that it can actually trigger a Lambda for us. And that Lambda can then go through and perform some kind of complex logic that we provide, which if it passes that, we can run the various tests. If those tests pass, we can actually put an approval response back to code pipeline to allow it to move to the next stage of the deploy. So the idea here is we want to automate the release process to each of these tiers, but we want to make sure that we're giving ourselves an adequate mechanism to do that in an automated way. So the best way to do that I found is using this approval process, approval trigger. So let's look at what we provide. So if we go into this manual approval stage, we can specify the SNS topic that we're going to subscribe to and send the message to. We can provide specific details. And so imagine if this is like a manual process where we were going to notify a release manager that things are obsolete, that this deployment is happening, or at least this stage of deployment is happening. We're going to send them a URL, and then we're going to provide some comments for them. Well, the same is going to be true for our Lambda function. So we're going to have this specific SNS topic. We're going to give it a URL, and then we're going to provide some details in the comments, which is basically going to be a JSON structure that gives specific details about this particular stage of the deploy. And so we can see the specific invocation that we want. We can see the function name that we're going to use, and we're going to specify the canary that we want it to execute. So creating a deployment test. Let's go through. So a change comes in. It's going to hit that approval. That approval is going to trigger that SNS topic, which will then hit a Lambda function that's going to register that test that needs to, or that stage. We're going to store that in a DynamoDB table, and then every minute we're going to have CloudWatch execute a function to evaluate the deploy. And so the deploy is going to hit that DynamoDB table, get details that we provided in the comments, and execute specific tests to make sure that there aren't alarms, we're meeting the time that we want, and that the specific usage of the app is working as expected. And then it'll respond back whether that deploy was successful or not. And that will then allow it to move to the subsequent stage of the build process. So if we look at each of these components, the Lambda function here, let's dive into that. This is a pretty straightforward Lambda function. All it's basically doing is it's got a specific event tied to it, which is the SNS topic. We're going to take that JSON structure from the comment. We're going to parse that for the specific records. We're going to write that to DynamoDB. Pretty straightforward stuff here. Now, looking at the evaluate deploy function, this is where it gets very personal to the nature of your application, what tests you need to execute, the specifics of your particular deploy, and we want to make sure that you're doing what's necessary there. So that's going to be unique to you, but what's not going to be unique is essentially how it responds back into code pipeline to approve it. So we'll dive into that portion of the code. We'll let you specify the specifics of your tests. So if we look at this here, we've got a code pipeline method for put approval, and it's got specific details that we've pulled out of that JSON string from the comment. And it'll report back in success or failure as to whether we can move forward. So how are canaries different from standard production servers? Well, like all production hosts, they participate in the serving of production traffic. They're configured as a production instance, so they're going to participate in the same CloudWatch logs and metrics that any other production environment would. So it's going to basically act no differently than any other production system, with one exception. They're going to have their own metric streams. So imagine you had hundreds of servers in your target group, and you've got this one canary, and it starts to fail. Well, our metrics are going to be based off of a specific number of failures in a particular time frame. And honestly, it might get drowned out amongst that large pool of servers. And so we want to make sure that our canary metrics are being monitored as a secondary stream. So we can monitor just those as we deploy our applications. So we can see immediately if there's an issue, and we get a clean metric from them. We still want them reporting back into the standard metrics, but the idea here is we want to validate against the canary metric stream for success of the deployment there. So now let's look at this context of evolving our pipeline. So now we're segmenting production or deployment environments, and we've modified the actual pipeline itself to accommodate for testing each of the segments and making sure that we're deploying successfully. So let's talk about what happens next. So evolving this further, we've got the idea of halting promotions. If we look at it in the context of a release getting deployed to production that then gets deemed as an error and now production isn't working, subsequent changes can compound that while our ops teams are trying to determine what the issue is and troubleshoot it. Developers we've tightened that flywheel, so developers are releasing new features and functionality, and that deploy process is now automated. We don't want subsequent changes affecting our ability to do an RCA on an issue on production. So we need to stop those subsequent deploys from reaching production. So let's look at build promotion blockers. So the idea here is we want to auto stop the deployment as soon as we detect some kind of failure. So we want the CloudWatch events to be triggering that synthetic traffic. As soon as synthetic traffic tests see that there's an issue, we're going to trigger a CloudWatch event, which will trigger an alarm, which will then trigger an SNS topic to go through and trigger a Lambda function to stop the stage transitions for code pipeline. So now subsequent deploys can come through once we fix that. So the idea here is once we've stopped that promotion, we've fixed the issue, subsequent changes can then come through and work as expected once we've resolved that and remove that blocker. So let's look at what that function looks like. How do we disable that stage? So if you look, we've simple call to code pipeline for disable stage transitions. We're going to have a JSON structure for that function that basically describes the stage name, and provide a reason for why we're making put this block in place. So if anybody comes into code pipeline, they can see, okay, there's the stage transition has been stopped, and if they click on it, they can see it was disabled by the automated check. So let's look at this again. You're about to enable transitioning from integration to prod, and you can see why it was disabled by Lambda. You can provide a more realistic, meaningful description as to why this was stopped here. But the idea is we want to put this block in place until the operations team has fixed the issue or addressed the problem there, and then somebody has to manually come back in and enable that. So they have to click that enable button to allow subsequent builds to make their way through to production. So looking at this again in the context of maturity of our pipeline, now we've implemented some health checks on the actual pipeline itself. So at this point, we're synthesizing traffic, we're segmenting our deploys, we're checking the health of each of the instances, we're checking the health of each of the segments, and we're going through and making sure that our actual deploy process or release process has health checks as well. So if we look at it from that growth, got ahead of myself a little bit here. You can see that all things are healthy, and we've evolved from having no automation to a high degree of automation, but a high degree of safety checks along the way. And you can evolve these as you go and make it work better for your team and specific requirements of your process. So the idea is we want to make pipelines safer. So we've implemented automated testing notifications. We want to make sure we're keeping the pipelines unblocked. We're going to identify production issues quickly. So that's one of the ideas with synthetic traffic. We want to make sure we're doing continuous production testing every minute to make sure things are operating as expected. And then we want to make sure that we're safely deploying those changes to our environments so that if we do have a deployment failure, we're seeing it early and we're limiting impact on our customers. And then if we decide that we need to stop deployments to production because of some other issue, we're halting those promotions. And so bringing it all together, this is the idea of CI/CD. And the goal here is to automate as much of this process so we can tighten up that flywheel and make your teams go a lot faster as far as the releasing of features and capabilities for your end customers. The idea at the end of the day is your customers are your lifeblood. We want to be able to wow them and deliver on their needs. And one of the best ways to do that is to help enable your teams to do a better job of being able to detect issues with their code and help them be more successful in developing new features and capabilities. So if any of you want to experiment with some of the examples we used today, you can go to any of these URLs on GitHub. So we've open sourced some of these examples, so you can look at the AWS code build samples. We've got synthetic tests samples that you can use, and then we've also got the code pipeline block production sample as well. So you can go through and use these as a base and kind of grow from there. If you have any questions, we'll be around for Q&A. I really want to say thank you to all of you that participated today and joined us. I wish you luck in your journey, and if you have questions along the way, definitely let people at AWS know. Reach out to SAs. Feel free to participate in the community. We welcome all of you. Thank you.